Alright, so in this particular video, we have a statement here that says if the force of attraction F between the two objects of masses m1, which is 10 kilogram, m2 is 80 kilogram, is 3 times 10 to the negative 6 newtons. It wants us to find the distance between the objects, distance r. So in the diagram here, the distance from center to center is known as r here. And then statement B says if the mass of each body is double and the distance between them is half, what is the new force between the two objects? Okay, so let's go ahead and crack out part A and B. To do part A, all we have to do is notice in this diagram that according to Newton's law of attraction, that there are two vectors pointing toward each other. They have the same magnitude except opposite direction. So in this case, we say m1 is attracted to m2, and then m2 is also attracted to m1 with equal magnitude. Okay, so these two values for F will be the same because it's called the force of attraction. All right. In order to do so, all we have to do is apply Newton's law of attraction function. Here we have F is equal to capital G, the universal constant, and then m1 times m2 over r squared. R in this case in the diagram is the distance from center to center for these two masses in green and blue. All right. Well, we're given everything, and it wants us to find r. So let's go ahead and move variables around real quick. R is r squared here in the denominator on the right. It asks for r, so let's go ahead and isolate for r squared to get it by itself. In order to get r squared by itself, I would just simply move r squared to the top left and then move f to the bottom right. Or you can multiply both sides by r squared and then at the same time divide both sides by f, which is the same skill. Okay, so here I have r squared is equal to g m1 m2 over f. Well, I have everything. I know G, I know M1, M2 is given, and F is also given in the problem as 3 times 10 to the negative 6 newtons. So here we're just going to plug and chuck on a calculator. I went and substituted big G, the universal constant, for 6.67 times 10 to the negative 11. And then M1 is 10, M2 is 80. And then the force given here is 3 times 10 to the negative 6. And then if we simplify our calculator work and cancel our units out, you'll get this particular value. So R squared is going to equal to 5.33 6 times 10 to the negative 8 divided by 3 times 10 to the negative 6. Okay, so I went ahead and multiplied the numerator just so that it can shrink down to one value. If you can do all this on your calculator in one scoop, great for you. If you can't, I highly encourage you to just simplify the numerator and then get one number, and then from here divide the numerator by the denominator so that it prevents calculator errors. All right. But you notice here, Newton's in the numerator and denominator is going to cancel out. That'll leave us with units of m squared. So our final answer here is going to be 0.01779 meters squared. However, this is r squared, so we still need to square root the whole entire left and right side. So therefore, square rooting r squared is going to give us r, and then square rooting 0.01779 is going to give us an answer of 0.133 meters. So that is our answer. Okay, it says the distance, so that is it. No need for direction or anything like that. All right, part B asks if the mass of each body is double and the distance is half. So these objects are going to get more massive, but you bring them closer together. Half would imply that the distance is now closer together. Okay, and it wants to know what is this new force in terms of the F given. All right, so all we have to do is do a little ratio problem here. Before and after, if you saw my first video, we set the before with just a simple statement, F is equal to G m1 m2 over r squared. Here, r is the distance, once again, between these two objects. So whatever the diagram calls it, just go with it. If they call it x, go with x. If they call it lowercase d, go with it. Here in this diagram, it just happens to be r, so I'm just going to replace the denominator with the variable given in the diagram, which is r. All right. And then all we have to do is simply change what it tells us to change. So you notice here on the right side, I put f of g new, or f new if you want to call it that. G remains constant because that's the universal constant. Here I have 2 m1 because it says the mass of each object is double, so 2 times m1. In addition to that, I also have 2 times m2. So both these masses are being multiplied by 2 because it said so. The denominator, in parentheses though, is r divided by 2. It's r divided by 2 because half would imply you take that value and divide by 2. So if you do this properly, you should get, in your next step, a 4 in the numerator. Because 2 times 2 is 4, and that's where that 4 came from. And in the denominator, what I do is I distribute the exponent, the r which is on top, so I get r squared. And then I also distribute the exponent to the 2 in the denominator, so 2 squared is going to be 4. So here we have 4 gm1m2 divided by a fraction, the fraction being r squared divided by 4. So in algebra though, anytime you divide by a fraction, the rule is to multiply by the reciprocal. Alright, so what I want to do is I want to take the numerator and then I want to multiply by the reciprocal of the denominator. Reciprocal would imply that you flip this denominator upside down. So instead of the 4 being in the denominator, it is now in the numerator. And then instead of r squared being in the numerator, it is now in the denominator. So as you can notice here, we have 4 times 4, because both of these are in the numerator. So this 4 is in the numerator, that 4 is also in the numerator. So you get 16, and then everything else stays the same. gm1, m2 is on the top, and then the only thing that remains in the denominator is r squared. So what I have written out here is just gm1, m2 divided by r squared. So the 16 in the front is what's important, okay? So right away, hopefully by now you know what the answer is. Well, we know from our statement in the left chart here is f is equal to gm1m2 divided by r squared. So anytime you see gm1m2 divided by r squared, you set that equal to f, okay? So I'm just going to highlight these statements because they are the same. So gm1m2 over r squared can be, and I will go ahead and substitute it for f. So in this case, I would say it's 16 times this box. And this box is simply f based on the information on the left side. So our answer would be 16 times the original force, okay? And if it wants a value, then you would take 16 and times it by 3 times 10 to the negative 6 newtons. But if it's just wants an answer in terms of variable, the answer would be 16 times. So the new force is 16 times that of the old force. All right, I hope that helps. Stay nerdy. Don't be bye.